Hello everyone, welcome back to the Seaborn series. In this video, we are going to look into the Seaborn Displot in detail. Displot is mainly used to check the distribution of the numerical column. So we are using the same automobile dataset which I have used for the earlier Seaborn visualization. Uh, so let's start. So first, I'm going to draw a simple displot. And when I say simple displot, by default, it is going to draw a histogram. So let me show you. So here what I have used the Seaborn disk plot, and I have used the same automobile dataset as I told you earlier, and I have used this engine size column. So this engine size column is a numerical column. Now let me run this code. So we can see here it has created a kind of a histogram. So this plot, when we try to create a disk plot, by default it creates a histogram showing the distribution of the engine size. Like for example, 50 to 100. Okay, this is the size. Okay, and what is the count or the frequency of that particular size engine size of that particular car. Okay, so now in the second example, we are going to draw the distribution plot, but it should be in the form of a KDE. So when I say KDE, a kernel, it's called as the kernel density estimate plot or KDE plot. It is a way to visualize the probability density of a continuous variable. It provides a smooth curve that represents the distribution of the data. Unlike histograms, which we have seen in the previous example, which is in the form of a binned structure. So let me write down the code for you. So here we go. And when I run this code, so we can see here it's in the form of a curve, and it's showing the probability density of the continuous variable of this CTMPG which I have used. So I have used the CTMPG as the numerical column here. So is going to tell us the distribution of the data. Now, the next example is, but please pay attention that here the most important parameter is the kind. So with the help of the diskplot function, we can create we can show the distribution in a different way. We can show it by default in the form of a histogram. We can show it in the form of a KDE. And there's one more way in which we can show show the distribution. So that is in the form of a ECDF. So let me show you. So here we have used the kind is equal to ECDF. So when I run this code, okay, so this is basically empirical cumulative distribution function. When I say ECDF, it's this cumulative distribution function. So this function basically shows the cumulative frequency of the data points up to a certain interval, or up to a certain value. It is a way to visualize the proportion of the observation below a given value. So we can see here, okay, that this is being in the rise, which is showing that how the cumulative frequency is being used here, how it's being plotted here. Now, next is we can use it for the rug plot also. So let me first draw the diagram. So this is the code for doing it. So here we are using this parameter called as rug is equal to true. So not this one. Let me use this code. Yeah, so here we have used this rug parameter, which is rug is equal to true. And we have used this distribution plot method. I'm using the same CTMPG data. Now, when I run this, what happens here is a rug plot is a compact way of adding small tick marks. You can see here the small tick marks here along the x-axis of a plot to represent the individual data points. This can help us to see the distribution and the density of the data points more clearly. Now, when we set the rug value is equal to true, okay, so these tick marks are being added in the bottom. And here, these tick points basically represents the points or the actual values of the city mileage column, city mileage numerical column. Now, let me draw one more diagram where we can show the rug plot and the KDE together. So what we have to do here is nothing. We have to just use the same code which is being used above. And we have also added KDE is equal to true, which means that we are going to have the rug also in the data, in the diagram. And by default, since the kind we have not specified here, so by default it will be histogram. Okay, but since we have specified KD is equal to true, so you can see here a curve is also being drawn, and rug is equal to true, so we can see the small tick marks also here. Okay, so the other way is also that we can also add bins. When I say bins, it basically divides the data into a specific number of intervals. So we can see here, let me let me draw. So we have used bins is equal to 20. So what will happen here is our x-axis, which is the CTMPG, it's being divided into 20 intervals. Okay, so why we do this? We do this because to identify the outliers. If there is any uncertain patterns or if there is any disambiguous relationship. So in that situation, it helps us like, okay, between this to this value, the of the range, the data is behaving in this way. So for example, we can say here that that if we look at something around 35 to 40, the total number of data is very less. Okay, total number of data is very less. Or we can say 0 to 15, the total number of data points is very less. We have maximum values between 17 to 20. Okay, between that particular range. So this helps us in finding out the interval, what is the data's behavior in a fixed number of intervals. Thank you for watching this video. And also, I would say that please go through this Seaborn distribution plot official website. This can help. This can give you the idea about all the different parameters and the different way of using this distribution plot. And if you found this video informative and helpful, please subscribe to my channel. Thanks a lot.